Hey, good morning, everybody. So today is January 21st, and we are going to start looking at a couple new shapes today. They are the trapezoid, rhombus, and kite. So I'm going to try and make this short and sweet for you so you can get to your practice and answer any questions that you may have in class. But a couple things to know. These are not shapes, first of all, that you are used to finding the area for. So I'm going to give you the formulas here, but you definitely need to do enough practice that you remember them, because when it comes time to take the state test or even in class, you may or may not end up having these actual equations. So, area of a trapezoid, first thing you need to know is that it has two bases, right? You have the base 1 here, and then you have the base 2 there. Second thing you need to know is that there is a height, okay? And that height is a 90-degree angle from the top to the bottom, so we call that h, or some people call it the altitude. All right, so the area of a trapezoid, what you do is you take those two bases, you add them together, okay, and then divide by 2, and then you multiply that by the height. So it's kind of like the mid-segment. Remember, we worked on the mid-segment before, where you go right down the middle? So that's basically what we're going to do, is we're going to find the mid-segment height, and the mid-segment length, and then we multiply it by the total height. So it's an average of the two bases multiplied by how tall it is, okay? All right, rhombus. Rhombus, two things to know. Number one, this is the diagonal from peak to peak, and this is going to be called diagonal 1. Second thing to know is that this is diagonal 2, okay? And it's, again, from peak to peak. So in a rhombus, pretty simply, it's very close. You're going to get the area by taking the first diagonal and multiplying it this time by the second one, and then dividing by 2. So notice before you got base 1, base 2, but you're adding them. In a rhombus, you multiply them. Okay, how about a kite? So the difference between a rhombus and a kite. Rhombus has 4 equal sides, right? Kite has 2 pairs of sides that are equal, but they're not all 4 equal. So that's the difference between a rhombus and a kite. But a kite, ironically, you find the area the exact same way. This is diagonal 1, this is diagonal 2, and you take those, multiply them together, and divide by 2. Okay, so whether it's a rhombus or a kite, take the area of the diagonals, multiply them together, divide by 2. So there will be some times where they don't give you the diagonal length, and you might have to figure it out using a triangle, and that's okay. You can do the same thing here with a trapezoid. Sometimes they won't give you the height, but they'll give you these two side lengths, or maybe they'll give you an angle. So trig is going to be important when you're talking about these shapes. You might have to use some trig to figure them out. All right, let's go through some examples, shall we? Find the area of the following. This is obviously a trapezoid. It's got a base and a base, and then you have a height, right? So area of a trapezoid, base 1 plus base 2 divided by 2 times the height. So in this case, you got 8 plus 14 divided by 2 times 5, which is, let's see, 8 plus 14 is 22. 22 divided by 2 is 11. 11 times 5 is 55. And since this is area, remember it's the units squared. Okay? All right, rhombus. Rhombus, so we have this diagonal is 9, this diagonal is 5, so we multiply those together. 9 times 5 divided by 2. 9 times 5 is 40. 40 divided by 2 is 20. So the area of the rhombus here is 20 meters squared. Right? Because it's, again, diagonal 1 times diagonal 2 divided by 2. Same thing here, whether it's a kite or a rhombus. This looks to be like it's a rhombus to me. Okay, and I think it even says, it says it's a rhombus, so that means all of these outside edges are 50. Okay, this is 40, this is 40. Okay, so in this case, we have the full diagonal is 80. So one of them is 80. What's the other one? Well, we don't actually know. We got to figure this out. Well, this is one of those cases. I told you, you gotta maybe use trig or Pythagorean theorem. So you have 40 squared plus we'll just say x squared equals 50 squared. Now, you can compute all that, or, as I talked about in class, you could remember the special right triangles that we had Okay, and you could use this, or you could say, wait a second, this is a 5 and a 4, so this must be, if it's a right triangle, 3. So this is 30. So this would also be 30. Right? So x should be 30 when you get done with that, which means you'd have 80 times, not 30, I'm sorry, 80 times 60, because you want both halves of the diagonal, divided by 2. So 80 times 60, basically the same thing as 40 times 60, which would be, what, 2,400 inches squared. Okay, so there's the area of that one. So again, might have to use Pythagorean theorem, you might have to use trig, but really not that complicated. Excuse me, got a little sip of my coffee here. All right, find the area of each kite. Round your answer to the nearest tenth. Okay, so 4.5, 4.5, this is 2.5 right here. Okay, this is 5. All right, so since we know that these two pieces are congruent, by the way, that's how we knew that both of these were 4.5. But area is going to be 4.5 plus 4.5 gives you 9 times 5 and 2.5 gives you 7.5 divided by 2. 9 times 7.5, don't know that off the top of my head. 9 times 7.5 is 67.5 divided by 2, which is 33.75. So there's your area of that kite. Okay, now it does say round to the nearest tenth. Always pay attention to the directions. So the answer for this one would be 33.8. Okay, that's feet. Sorry. All right. Okay. So a couple more examples here. They don't tell you what type of shape they are. You have to be able to recognize it, but I think it's pretty self-explanatory. This is a trapezoid. Okay, you got the top, you got the height, you need the base. Well, problem here is we don't have that base, right? But remember that a trapezoid can be broken up into two of the congruent triangles and a rectangle. So we already know this is 13 on this bottom side, but we have to find this. Well, again, this is a right triangle, so we could use x squared plus 9 squared equals 15 squared. Again, this is a special right triangle. 3 times 3 gives you 9. 3 times 5 gives you 15. So 3 times 4, 3, 4, 5 triangle is 12. So x should be 12. So that means that part's, this part's 12 and this part's 12. So the other base, so you have one base is 13 plus our other base is 12 plus 13 plus 12, which is 25 plus 12, which is 37. So 13 plus 37 divided by 2 times the height, which is 9. Okay, so in the area in this case, let's see, 13 and 37 is 50. 50 divided by 2 is 25, so this is 25 times 9. 25 times 4 is 100. So times 8 is 200, so this is 225. Okay. Next one, moving right along here. Now, even though this one's flipped on the side, we still have its base and we have its other base. And even though it's not an isosceles trapezoid, that's okay. We can still find it using the same formula. Okay, but downside here, you have to figure out what the height is. We don't have the height. Okay, so we know that it can be made up of a square or a rectangle. So in this case, we have 26 as this outside. We know that this part is 30, right? And that makes this part 24. So x squared plus 24 squared equals 26 squared. Now I'll tell you, this is a Pythagorean triple, but we haven't done it a whole lot, so I don't expect you to know this one. 24 times 24 is 576. 26 times 26 is 676. Okay. When you subtract 576 from both sides, you get 100, which means that x is simply 10. Okay, so now you can find your area. You have the base 1, which is 30, base 2, which is 54, divided by 2, times the height, which is 10. So this would be 84 divided by 2 times 10, which 84 divided by 2 is 42, so this would be 420. All right, last couple here. This is a rhombus. It's got all four sides the same. Okay, rhombus, you take one diagonal and multiply by the other. So one of these is 30. We don't know what the blue line is, though. We don't know what this is. We know this is 30. We don't know what this line is. And then divide by 2. So how can we figure it out? Well, remember, the properties of a rhombus tells us that all the angles in the inside are right angles. So we know one of these is 15. We know this is 17, so we just need to find this. So again, Pythagorean theorem, we got a triangle with a right angle, and then 17 is across from that right angle, so it's the hypotenuse. So once again, we use Pythag. So 225 and 289, I think it is, off the top of yeah, I know it is. Okay, subtract 225, and you get another very nice number, because this is also a Pythagorean triple. Take the square root, so x is 8. So this is an 8, 15, 17 triangle. So that means this is 8, that means this is 8. So that would give us 16. All right, so 30 times 8, when you divide 16 from 2, is 240. Okay. So again, Pythagorean triples, very prevalent here. Pythagorean theorem, very nice to use in these examples. Okay, last one before we get to a word problem. So we have the base. This part is 16. This part is 2. So we know the whole base here is 18. Other base here is 10 divided by 2 times the height. Problem is we don't have the height, right? We need that. That's this. But we do know that this is a 60, this is 12, so we have a, and this is 90. So what we have is a 30, 60, 90. 30, 60, 90. X, hypotenuse is always 2x, and then x radical 3. So in this case, the hypotenuse is actually 12, right? So 12 is equal to the 2x part of the 30, 60, 90 triangle. Well, I can solve that. Divide by 2 tells me that x equals 3. X equals 6. So this height is going to be 6 radical 3. Okay. All right. So we can figure that out to be a decimal. We're going to round to the nearest tenth here. 6. And let's see, radical 3 is like 1.21, 1.4 something, I think. Let's see, radical 3, 1.73, duh, I knew that. Okay, so radical 3 times 6 is about, we're gonna round to the nearest tenth here, is about 10.4. Okay, so we got 28 divided by 2 times 10.4, which is 14 times 10.4, which is, the area of this is 145.6 centimeters squared. So there you go, a little bit of Pythag. In this case, we used 30, 60, 90. You could have also used, let's see, opposite and hypotenuse. You also could have used sine of 60 degrees, and that would have given you that as well. Okay, area of a trapezoid, 60 square centimeters. Well, it's a trapezoid. So you got base 1 plus base 2 divided by 2 times the height. So 60 is the area. One base is twice as long as the other, so x is equal to 2y, right? Or you could say that base 1 is equal to 2 times base 2. And the height is 5 centimeters. So height is 5 divided by 2. So if base 1 is equivalent to 2b2, that's what we're going to replace it for. So this becomes 2b2 plus b2, which means when I have 2 plus 1, I get 3 of base 2 divided by 2 times 5, right? So we're going to kind of work our way backwards here. So instead of times 5, well, you could multiply it by 5. I take that back. So we have 60 equals 15 times base 2 divided by 2. Okay, well, let's now multiply by the reciprocal, 2 over 15. And that gives me 120 divided by 15 equals base 2. 120 divided by 15 is 8. So base 2 is equal to 8. So what does that mean base 1 is? Well, base 1 is 2 times that number. So base 1 is equal to 16. Okay? So you have one base and the other base. All right, so you got some practice. Go ahead and finish that up for homework tonight. Submit it in